Welcome to my part 3 of problem solving in physics, and in this part I will focus on the number 3 of the problem solving steps, which is perform dimensional analysis at each step. A lot of us have studied, or everybody studies this in while studying units and dimension. And let me put it here. M for mass, L for length, and T for time. And in this video I'll show you how we use the concepts of dimension analysis to solve problems, or to make sure that we are not making mistakes. So let's first read the question. That's the first step. We should understand the problem first. So let me draw the diagram. So there is a cart. I'll do my best. Okay. This is a cart, and it's a missile launcher. Okay. I don't like the idea of wars, but it's a problem of physics, so we'll do it. Okay. So this is a missile launcher, and says that it's moving at a constant velocity 30 meters per second to the right. So let me write here, is moving in this direction with the velocity v, and I write the values here. So v is 30 meters per second. Okay. And it launches the rocket vertically upwards. So let me delete this thing. So I cut this and make it vertical. So I wonder, I could have also just rotated it. Okay. So we have the missile is vertical. Like this. Okay. And the missile has an initial vertical velocity 40 meters per second relative to the cart. So I write, and let me call it of the missile is 40 meters per second. All right. And a very important thing to note, that it says it is relative to the cart. So let me draw Earth here. So it's not relative to the Earth, it's relative to the cart. How high does the rocket go? That's the first question. So because of these two, the rocket will take a path which will be something like this. And why so? Because the rocket has two components of velocities. One because of the cart, which is in this direction, and one in the vertical direction, which is Vm. And let me write C for this is the cart velocity. Okay, so rocket has Vm in the vertical direction and Vc in the horizontal direction. Okay, so the first question is, how high does the rocket go? So suppose let me use color blue. So this is the height, and I'm not taking the height from Earth because I don't know how high the cart will be. We can calculate with respective to. So this is the okay. So this is H. And we have to find the height. That's the question number 1. So let me write here the height you have to know. How far does the car travel while the rocket is in the air? Alright, so let me use color yellow and say that the car travels I don't know how long, but let's say the car travels a distance of L. So L is also unknown, and number C, the question number 3, that this, let me use the color red, that this, suppose, is let me call this C, and let me call this L of the rocket. So this was C, and this is L of the rocket. So we need to find out these 3 things, and let me write G, gravity, and we don't know, they have not given, so we will use the standard value of gravity that is most common. So with this picture, I have this confidence that I have understood the problem. Now enter dimensional analysis. So let me bring this down. Okay, let's erase a few things. Okay, so what is the dimension of velocity? You can go to the video of part 1 and you can see that velocity is L t minus 1. This is also L T raised to the power minus 1. Height is L. LC is also L. LR, so LR I can write the difference between so LR is also L. G is, want to think about it, G is L T minus 2, which is of acceleration. Okay, and we have our question number 3 was, how does the rocket land relative to the cart? So that will be, the third question is actually this one, is LR minus LC, and the dimension of this is also L. I think I have used capital L for both length, but you understand. So now we have written down the variables, and see how diligent I am about using symbols and not the actual values. Now the next question is that for a problem like this, which rules do I use? So we are talking about which principle to use. So the formula that will help us is this: V square is equal to U square minus 2G H. So V is the final velocity, U is the initial velocity, so we don't know that the final velocity will be 0. So 0 square is equal to Vm square minus 2Gh. Now why do we use this minus? Because G is in the downward direction, H is in the upward direction. So H will be Vm square divided by 2G. So we have this symbol, and this was our question number 1. So let me mark it here. That will come back to this when we need to calculate the height. Now time t. Let's find out the time it takes to reach that point. So time it takes to reach height H. So the time will be, let's the formula is V is U minus GT, and V is 0, so this implies that 0 is Vm minus gt. So time t is Vm divided by g. So this is an interim value. Now let's look at LC. So LC will be the velocity of the cart is equal to velocity of the cart multiplied with t, which is velocity of the cart multiplied with Vm divided by g. Now LR, does the rocket have any horizontal component other than the cart? No. So LR will be equal to LC. So this is our B and this is our C. Now let's perform dimension analysis on each of these. So H, what do you expect the dimensional analysis of H to give you, this equation? So we know that H is L. So let's see if Vm squared divided by 2g also gives you L. So we know that Vm squared divided by 2g will be LT minus 1 divided square divided by, there's no dimension for constant, g is LT minus 2 raised to the power minus 2. So this leads to L square T raised to the power minus 2 divided by L T minus 2. So this cancels and this cancels, we get L. So we are relieved that H was L and we got L here. So most likely this is correct. Now we move on to the next one. So here LC is VC multiplied with T, which is VC Vm, and let's write down VC is LT raised to the power minus 1 multiplied with LT, which is the Vm, and divided by LT minus 2. It's very similar to what we got in A. So it's very similar. So this implies that L square T minus 2 L T minus 2 cancels. Again we have L, and this is no brainer, this is L. So you see here that Vm squared divided by 2g does not look like length intuitively. But by performing this dimensional analysis, it becomes very clear that it is indeed a length. And we saw this. So this technique, people who are able to score very high on NET and JEE, they perform this at every step. So in the beginning, it will seem like a laborious task, but once you get used to it, it becomes automatic that at every step you go on checking. So let me write it here. By performing dimensional analysis at each step, you improve the chances of avoiding errors. Because just imagine that here for h, and let me write it down, let me copy it below, it'll be easier. So my h is Vm square divided by 2g, and God forbid if you made a mistake and you forgot to put this 2, so instead you end up writing Vm divided by 2g for h. And let's see, this is mistake but happens. So let's see what the dimension analysis gives you. L t minus 1 divided by L t minus 2, so L gets cancelled and you get t. So instead of finding a length, you end up finding time. So this is the kind of mistake you can make. Now let's plug in the values. So h will be Vm square and Vm square. Vm was 40, so 40 square divided by 2, 9.8. So this is 40 multiplied with 40 divided by 2 multiplied by 9.8, and the value of this, let me calculate, is 81.63 meters. And now I put the value of LC, which is the cart, and that's the velocity of the cart, and time t, so which is Vm divided by g, which we got from here, G over here. Oh, I have made a mistake. This should be 2 because the rocket is going up and then coming down, so it reaches this point at time t and then comes down at another time t. Okay, so I made a mistake. It's 2 of this twice, and you will appreciate that by multiplying 2 here, it does not change the dimensional analysis because it remains the same. So now I put the values. 2 VC was 30, VM is 40. Let's take the value of 9.8 and let me go back and do calculation on my calculator.